Hi, this is Dick Simon. I just wanted to let people know we're going to give it a few more minutes as there are a number of people still calling in or connecting. So we will connect the conference in just a couple of minutes here. Welcome to everyone who's on. Thank you for being so punctual, but to not have a number of people coming in late, we'll just give it a minute or so. I will be rejoining you shortly. All right. There'll still be some more people joining as we go, but let me say good morning, good afternoon, and good evening to YPOers and guests and friends around the world. Welcome to this global conference call with Robin Carhart Harris. This is being put on by the YPO Psychedelic Medicine for Mental Health Group, and it is part of a series of bi-monthly, which is now going to become monthly calls and opportunities to learn from top experts in the world about the exciting developments and questions in this space. Before beginning today's call, I just wanted to give people a follow-up on something that has happened, or a couple of things that have happened with Rick Doblin, who gave our most recent call, the founder and executive director of MAPS, or the Multidisciplinary Association for Psychedelic Sciences. For those who were not on that call, they're proceeding with clinical trials in phase 3 in the US with the FDA and Europe with the European Medicines Agency of MDMA for post-traumatic stress disorder. They just received their results of the first half of the trial, which is called an interim analysis, which basically is the most promising results you can possibly get in a clinical trial, indicating that the initial data with 90% probability is leading to a positive outcome and without the requirement for increasing the number of patients in the program. So given all that great news, I'm personally redoubling my efforts, helping them get across the finish line. And if anyone's curious about that, please reach out and let me know. I'll be happy to help you. And as well, I'm continuing to do all the work with Mass General Hospital's Psychedelic Research Center as we build a world-class institution. So the format for today's event, this is an hour-long call, webinar, and Robin Carhart Harris will be speaking for about the first 20-25 minutes, followed by ample time for questions and answers. To submit your questions, use the questions tab which has like a pull down arrow, and just submit your questions there. It's on your GoToWebinar screen. So we're completely excited and honored today to be joined by and having Robin Carhart Harris speaking with us. Robin Carhart Harris is absolutely the leader in the space, in this entire space. He founded and runs Imperial College's Psychedelic Research Center, which was the first psychedelic research center affiliated with the university to be created anywhere in the world. He's authored or co-authored over 50 papers and academic papers, and has done a lot of the really important seminal work in this space, connecting neuroscience and the potential for psychedelic-assisted medicines. So without further ado, we're all here to listen to Robin. Robin, it's all yours. Thank you very, very much. And so again, Robin will speak for about 20, 25 minutes. If you have questions, put them into the questions queue, and then we'll have a chance to answer them when Robin is concluded.
Well, good day to you all, and thank you, Dick, for that very generous introduction. I'm very pleased to be with you all. Hopefully you can see my screen here. So I'll try and speak for about 25 minutes on most of this will be principles really about how classic psychedelic compounds work on the mind and the brain, and also very much tying in with based on what we're learning about how they affect the mind and the brain, how that might be able to explain their apparent therapeutic value. So it's a multi-levels talk. The first level that we will look at is the molecular level. So here we have three different tryptamine psychedelics. The most sort of famous tryptamine that you'll most likely all have heard of is serotonin, 5-hydroxy tryptamine. Now, what isn't always apparent to everyone is that a lot of these classic psychedelic drugs that you'll be familiar with, that you'll all have heard of LSD and perhaps psilocybin and DMT and ayahuasca, but perhaps you weren't so aware that the chemicals themselves, their molecular structure is very similar to that of serotonin. And serotonin is a chemical that occurs naturally in our bodies. Most of it actually occurs outside of our brains. In the brain, it's involved in modulating a range of very important functions, but actually about 90% of it occurs in the gut. So as is often the case in nature, you get one particular thing doing a number of different things. So very important in the brain, but let's not be too brain-centric. Serotonin is involved, in different functions throughout the body. So the main point is this similarity in the molecular structure, the chemicals themselves to serotonin. You can see psilocin there, which is the metabolite of psilocybin. We do our research with psilocybin because it's the more stable compound. It's what we call a phosphorylated ester of the psilocin, but really it's the psilocin, and you can see its structure there on the left, that is working on the serotonin system in a particular way to produce the interesting, weird and wonderful effects of this compound, psilocybin, psilocin. Then you could see DMT, an even simpler molecule. It's pretty well established that DMT actually occurs endogenously in our bodies. What's more contested is its functional relevance, in the sense that the amounts that have been detected in cerebrospinal fluid, for example, the fluid that bathes our brains, is quite minuscule. So there's question marks about its functional relevance, whether it spikes up during extreme states. There's now some evidence that it does during the process of dying. DMT spikes up, but then the selectivity or the specificity of that change is something that's in question, in that a lot of, I guess, the contents of cells are going to spill out during the process of dying. So serotonin itself massively spikes up during the death process as well. So whether there's something specific about that big spike in DMT accounting, for example, for the near-death experience is a very intriguing, but as things presently stand, still open scientific question. So you can see DMT there. DMT is the main tryptamine psychedelic, really the only tryptamine psychedelic to my knowledge in the Amazonian brew ayahuasca. DMT, when it's ingested, is ordinarily broken down in our stomach and our gut, and then it doesn't get into the brain. So when people take DMT, pure DMT, they either smoke it or they might inject it. With ayahuasca, what they're doing is they're combining leaves containing DMT with vine that contains chemicals that inhibit enzymes that will break down the DMT in our stomach and our gut. Monoamine oxidase inhibitors, they're called. They're in the vine material. And so, it's this clever, coming upon this combination of different natural ingredients that accounts for this, hundreds of years old cultural phenomenon of taking this ayahuasca brew in certain parts of the world, particularly in and around the Amazon basin. LSD discovered its psychoactive effects discovered in this month in 1943 by Albert Hofmann. I think the 19th of April, so we're not too far away from so-called Bicycle Day. He took the LSD, jumped on his bike and cycled through Basel in Switzerland and had the beginnings of a somewhat nightmarish trip, the first ever recorded psychedelic trip with LSD in 1943. You can see again that basic tryptamine structure to LSD shared with serotonin. So really, in making this point in terms of the similarity between the molecular structure of these psychedelics, these tryptamine psychedelics and serotonin, it's hinting at how these drugs work in the brain, that they work on the serotonin system and they hijack the serotonin system in a particular way. And I like to go, at this stage at least, with a pharmacological definition of what I consider psychedelics, rather than necessarily going by something like a psychological definition, because that's quite sort of slippery and abstract. It's appropriate, though, to address the etymology of the word psychedelic, where it came from, coined in the mid-1950s by the British psychiatrist Humphrey Osmond, working in Canada as a psychiatrist, and he struck up a friendship and correspondence with the author Aldous Huxley, and between the two of them they came up with this word psychedelic, combining two ancient Greek words, psyche for soul or mind, and the delic component is referring to making visible, revealing, or making manifest. So psychedelics are sometimes referred to as meaning mind manifesting agents. Now, if you go by that as your definition, you can start including a lot of different compounds and states as being psychedelic. I think that's absolutely fine, but as a scientist, we're often hankering after clearer definitions, and the pharmacology does at least offer that at this stage. In the future, maybe we'll get to, the kind of holy grail, a sort of mechanistic biological explanation for what accounts for the mind revealing properties of these compounds. We're not there yet, but maybe one day we'll get there. So let's start with the pharmacology. We know that these compounds work on the serotonin system. We know that they work on a particular aspect of the serotonin system. So what is that? Well, it's the serotonin 2A receptor. The serotonin system has at least 14 different receptor subtypes. They all do quite different things, sometimes opposite things to each other. We know that the 2A receptor, one specific receptor of these 14 or so different receptors, is really important for how psychedelics work. And so there's important things to say about that. Where are those receptors in the brain? You can see this PET image there where those receptors are labeled. And you can see that they're quite spread out in the cortex of the brain, that wrinkly stuff that humans have so much of, really what defines us as different from other species in terms of our anatomy. There's a few things, but our massive brains and particularly our massive cortex is really what sets us apart, particularly in relation to body mass or body size. We have these just huge brains relative to other animals. And so where do you find these key receptors that psychedelics are working on when they're in that evolutionarily expanded aspect of our species? And they're not just, you know, broadly, homogeneously, evenly spread out. They're also highly expressed in high-level cortex, the kind of aspects of the brain that are concerned with particularly abstract, associative processing, quite high-level processing. We know that this receptor is important because if you block it and then give a psychedelic, people don't trip. That was established around about the late 1990s by Franz Wollenweider and in Zurich, and has since been well established by other teams in a variety of different studies. Sorry for the auto flicking over the slides. It's meant to keep me to speed. It doesn't always work. So I apologize for that, but I think it probably a good thing that we keep it on. Yeah, so we also know that the affinity or the stickiness of a psychedelic for the 2A receptor correlates very strongly with its potency. LSD, very high affinity, really sticks onto these 2A receptors, and that explains why you only need tiny amounts, super potent compound. Compare that to something like mescaline, much lower stickiness for the receptor, so you need much more. You need about 0.5 gram of mescaline, whereas you need 10 micrograms of something like 10-15 micrograms of LSD for it to have its subjective effects. You know, remember 1,000 micrograms in a milligram, 1,000 of those in a gram. So that starts to put into perspective the span of that range of potency of these drugs. Now look at this chart on the right. The slide will probably skip on in a minute, but let's try and focus on that chart. And you can see these points and these different axes. We have the intensity of the effects on what we call the y-axis here, the vertical. And then you have the occupancy on the x-axis, the horizontal here. So this is plotting the percentage of receptors, serotonin 2A receptors, occupied by psilocybin, taken orally, in different people, taking different doses of the drug. And what you see is that there's a relationship between the proportion of receptors, these things, that are occupied by the drug and how strong the effects are. That makes sense. But it's nice to see, and it's also further evidence for the role of this 2A receptor. The other thing that I want to add before we do properly skip on to the next slide is that this relationship isn't entirely linear. It's not just a bit more occupancy, a bit more intensity. It looks as though you hit a certain proportion of occupancy and then the experience jumps up. It becomes, sort of exponentially more intense. And it's important to realize that around the dose range that achieved this sort of 60% occupancy, that's about 20 milligrams of psilocybin. That's the dose range that's being used clinically at the moment in most of the studies. So this isn't a microdose range. This is up in a high dose range, the kind of work that's happening at Hopkins, NYU, with us in London and now elsewhere. Throughout Europe and North America, it's these big doses that are being used. These microdoses, it's difficult to know what kind of occupancy they're achieving, but this work is quite useful for addressing questions like that. So that's established. 2A receptor, crucially important for the action of these compounds. So then the next natural question is, what does that receptor do? What's its function? Why is it evolved? So So let's start with this theme of plasticity. What's plasticity? Well, it's the ability to change, and that might be a psychological change, it might be a change in our perspective, it might be a change in our behavior, or it might be a biological change or a neurobiological change. So we might look at neuroplasticity. And when we do that with psychedelics, stimulating the 2A receptor, we find that neuroplasticity, markers of neuroplasticity, jump up when you give a psychedelic, particularly in the cortex, that aspect of the brain here that humans have so much of, and where the receptors themselves are housed. So you stimulate those with the psychedelic and you induce neuroplasticity, changes in the function and the anatomy of the neurons. So a recent study here published in a leading neuroscience journal, bioscience journal, Cell, is showing this marked increase in synaptogenesis, these parts of the neuron that are particularly involved in communication being increased with exposure to psychedelics. Let's jump to some of these other properties: brain development, the role of the 2A receptor there, learning and also unlearning or extinction learning, the kind of thing that you'd really want if you had someone addicted to something, for example. They've learned the addiction, now you really want them to unlearn it. So that unlearning can be promoted by 2A receptor agonism. Learning, the aspect of learning is low-level learning. It's not like learning some, differential equations or something. That might be quite hard on a psychedelic. But if it's something very low level, implicit, below the level of consciousness, perhaps low levels of associative learning, like that air puffs happen when you hear a certain tone, that kind of learning is enhanced by 2A receptor stimulation, the receptor that psychedelics work on. We can also look at these other aspects of plasticity related to flexibility in thinking and behavior, and how there's evidence now that they can be increased with exposure to 2A receptor agonist classic psychedelic compounds. So that theme is now pretty well established. You can see this chart here, which is looking at the speed of learning being enhanced with exposure to LSD. The rats are actually, I think the rabbits are learning much more quickly when given LSD relative to given vehicle, placebo effectively. If you give ritanserin, which actually blocks the 2A receptor, you'll slow down that learning process. So 2A receptor, important for malleability, plasticity, the kind of thing that underlies learning. So then another related question is, well, why would we want this ability to change and learn? And under what conditions might you see an enhancement in this basic plasticity? And so this slide is addressing that. And this is a kind of work in progress. It's something that I've been working on with colleagues, with David Nutt, for example, and more recently with a US-based student as well, Ari Brouwer. It's this theme that the 2A receptor is likely involved in adaptability. That's why it's there in humans, our species that are particularly good at adapting to changing environmental conditions. Perhaps that's why we have so many of these receptors, given the massive expanse of our cortex housing these receptors. And so that ability to change, that ability to think on our feet, is also, there's good evidence that chronic stress, particularly, some evidence that the intensity of the stress as well, but mostly it's the chronicity, the long-term nature of stress seems to prime these receptors. It seems to increase their expression and also their functionality. Stress also upregulates serotonin release. So you could get a kind of perfect storm where you prime these 2A receptors, they're more available, then you have an acute stress and release serotonin, you get a lot of increase in activity at these receptors, you induce a state of markedly heightened plasticity, people are hypersensitive to the context that they're in, and then that might change them. And so that might be, you know, the aspect of our bodies and our brains that psychedelics as these pharmacological tools come in and kind of hijack and really sort of hammer that function that we have naturally particularly hard. And then if you harness that therapeutically, that may account for the therapeutic action of these compounds. So I've introduced this term with Ari Brouwer, pivotal mental states. It appeals to what some of you might have heard of as bifurcation, basically when things branch off. You might be going down one particular route, but then conditions destabilize, and now you might fall into either one side or the other. You're kind of forced to make a kind of, well, not conscious decision, that would be misleading, but there's the forced situation to kind of change state. And I think this notion is useful of these pivotal mental states in relation to psychedelics, because they very much speak to the principle that in and of themselves, these compounds aren't necessarily intrinsically therapeutically valuable. It's only when you manage the conditions in a therapeutic way, you induce this state of markedly heightened plasticity, instability, and then you try and kind of chaperone people in a particular direction towards wellness, that you get the desired outcomes. If someone was spiked with LSD at a party, they had pre-existing mental health problems, perhaps family problems, history of psychosis and trauma, worst case scenario here, they get a big dose of LSD and their beer at a party or whatever, you know, maybe they're going to go down another track altogether. And I think that, you know, that conditional aspect of the psychedelic experience is so important to emphasize. It's important to demonstrate scientifically, and we need more evidence to back up our strong assumptions about it. But I'll give you some evidence in that direction shortly, and just acknowledge that's the kind of model that we're working with, this drug times therapy interaction. Now, in a talk like this, it's important to address the safety profile of these classic psychedelics. Let me focus on psilocybin, mostly because most of the drug development work that's currently going on, aside from MAPS and MDMA, is focusing on this particular compound. So at least in terms of classic psychedelics, most of the work is going on with psilocybin. And when you look at its safety profile, it's particularly favorable. It's non-addictive, its toxicity seems to be very low. So it has a very high therapeutic index, or good therapeutic index, meaning that the kind of doses you would take in a therapeutic context are much, much lower than the kind of doses that might be considered toxic or even threatening to life. Now, that's not always the case with many medicines and also drugs that people take happily in a very legal way, like alcohol, you know, much tighter therapeutic index. It's very easy to overdose on a drug like alcohol. Paracetamol, you know, something else, you know, much tighter therapeutic window, easy to overdose. And yet, you know, it's all available to us all. Dysphoria, these are real risks now, the so-called bad trip phenomenon. We prefer, as others do, to refer to them as challenging experiences. The risk of injurious behaviors under psychedelics is quite real. That's why we try and provide a safe container for a psychedelic experience. Iatrogenesis, the risk that people's mental health might worsen after a psychedelic experience, is a real risk if people take psychedelics without proper preparation and favorable contextual manipulation. So these are all real risks. How serious those risks are differs in each component. Iatrogenesis perhaps lower than the others, but they are very much, you know, worth noting as quite significant limitations of psychedelics. We can also look at the side effects that are reported in clinical trials. Subacute headaches are quite common. About 40–50% of people will report headaches. It seems to be a dose-dependent phenomenon. It's subacute. What does subacute mean? It means it doesn't happen during the trip itself. It happens the next day and sometimes the day after. People will say, I've got a bit of a headache. I might not be depressed anymore, But yeah, I've got a bit of a headache and I took some aspirin and I feel much better now. But anyway, people do report that, and it's worth noting. And what accounts for it, we don't know. We know that headaches are very vascular. The vessels, blood vessels in the brain seem to account for a lot of things like migraine. So it might be something like a rebound vasodilation that accounts for these headaches. We don't think it's problematic. We don't know. And when people place it in the context of, say, therapeutic benefits with a psychedelic, they'll say, you know, I'll take a moderate headache the next day over, say, you know, 20 years of crippling treatment-resistant depression. This scale that you can see is from David Nutt's work, published in The Lancet, where he's done something interesting, which is with a panel of drugs experts, different aspects of expertise. They've assessed drugs for their different harms, relative harms to the users in blue and harms to other people in red. You can see alcohol at the top there. Of course, a lot of the just extent of use of alcohol will be accounting for the visibility of the harms that you get with this particular drug. Let's hope that, you know, as we, you know, people like me anticipate, mushrooms, psilocybin do become more available on a clinical level, that the harm profile doesn't increase appreciably because of that. It probably will a bit, but you know, at least let's put this in perspective. These were all the drugs that were looked at, and magic mushrooms are down the bottom for perceived harm. And this is quite a replicated assessment by independent teams now that tend to say, relatively speaking, no drug is without harm, no drug is without harm, and there are risks, real risks with magic mushrooms, but relatively speaking, the risk profile is quite favorable with this particular drug / potential medicine. So evidence overview in terms of this modern renaissance, as it's sometimes referred to, of clinical research with psychedelics. The way to do this is to summarize, because there's quite a lot now. And so there are some key themes to get across, some key take-home messages. One is that the therapeutic action appears rapid, whatever different disorder is being looked at. The drops, say, in depression scores are very rapid, on par with the kind of thing that you see with ketamine, for example. And unlike ketamine, the effects appear to be quite enduring. Ketamine treatment seems to require repeat administration. That seems to be less so with these classic psychedelics. So the effect appears to be more prolonged. And then this potential transdiagnostic action, where we're looking at a lot of different things here. Some you know, quite modest evidence in OCD, but some current work going on there. End of life distress, a lot of work there now, quite compelling initial findings for efficacy there with double-blind RCTs, having been done with very positive findings. And addiction, tobacco addiction, remarkable outcomes coming out of Hopkins. Also alcohol dependence, Michael Bogan shoots there. You know, replicating a lot of work done in the 1950s and 60s, really, that was showing particular promise with LSD therapy for alcohol dependence, particularly. Depression, we've done work there. You can see this chart from our open label pilot study. I'll tell you at the end, and please do ask me questions about it. We just completed a much larger double-blind RCT where we went head-to-head with escitalopram, an SSRI, a conventional antidepressant, psilocybin, 2 treatment sessions versus 6 weeks of an SSRI, head-to-head. Really exciting findings there. I'll talk about that at the end. So a lot of promise in depression, and then this is, of course, attracting people who, you know, take this evidence seriously. So regulators giving breakthrough therapy designation to 2 different development organizations trying to develop psilocybin therapy as an intervention, as a treatment for depression. Investments coming in, public opinion seems to be swaying, the Michael Pollan effect. Many of you will have read that incredible book. And the role of context, it's necessary. It would be remiss to not address context. The fact that in all of these studies, positive manipulation of the contextual setting has been done. There's been preparation, psychological preparation for the experience after careful screening. There's been music listening, and I think in every one of the modern trials, everyone's listening to music always throughout, carefully crafted music playlist. And then there's psychological integration after the experience as well. So let's not depreciate or neglect the role of that context in these studies. We could consider it a bias, or we could consider it an essential part of the treatment model. In some ways, it's both, but I do really believe it's an essential part. And this slide speaks to that. It's just a schematic that says, really, with psychedelic therapy, we're meeting in the middle between, the pharmacological age kicked off really in the 1950s in psychiatry, especially. It's dominated psychiatry ever since, really. And the older approach of basic psychotherapy here, I'd like to think, this is a paradigm shift in terms of being an example of where these approaches can truly meet in the middle, that there's a synergy between a drug action, the plasticity, the window of opportunity that is presented by that drug action, and then therapeutic work that comes in that window of opportunity. So the biopsychosocial model, I think introduced in the 1970s as a notion, is very, very relevant in this space. And I really do believe that if it can be done, if real world considerations around cost and such like don't preclude this, then really it is, in my view, the model of the future. The role of context, I said I'd present some evidence. Let me do this briefly and speak to psychedelicsurvey.com, which is, I think, still, maybe there's now a microdosing platform that does something similar. But for a long time, it's been the only prospective survey data collection tool that's existed. It collects data before, just before, soon after, and then longer term after a planned psychedelic experience. This particular survey looks at ceremonial use of psychedelics. And what we've found, and what I'm reporting here, this is close to being written up for submission and eventual publication, but these are the factors that were significantly predictive of a certain quality of the experience, emotional breakthrough, these big emotional releases, catharses, a lot of crying, that seem to be very important key mediators of long-term changes in mental health. In a study like this, where we have a very broad population, they're not necessarily depressed people, they're not addicted necessarily, they're just anyone and everyone. We look at well-being, very generic index of mental health. We see it reliably increase after the psychedelic at 2 weeks, 4 weeks. Also, follow-up work has shown at 6 weeks, 6 months as well. And this emotional breakthrough experience appears to be a key mediator. Personality trait absorption, our ability to be immersed in phenomena, is a strong predictor. Therapeutic intentions, emotional support, having supportive people around you, also listening to music, all appear to be particularly strong predictors of emotional breakthrough, which is that kind of pipe, if you want, that you really do have to pass through to reliably achieve these mental health improvements. That's speaking to a bit of evidence to support the role of context. Emotional breakthrough, what is it on a more personal human level? I was weeping, tears flowing out of me. It wasn't a painful crying. It was like a turning on the taps, like a washing out. These are patients from our depression trial, our first depression trial. I saw negative patterns in my life where if something bad happens, I used to just put it to the back of my mind. Afterwards, after the experience, I allowed myself to experience everything, even if it's sadness. Now I know how to deal with my feelings rather than repress them. Now, I talked earlier in that summary slide in terms of the Renaissance and summarizing the modern clinical trials and their findings about this transdiagnostic action. And I really want to sort of we'll draw towards the end on this theme of a transdiagnostic action, because it's something really exciting, with this it's in some ways old, some ways new, a lot of ways new paradigm psychedelic therapy in psychiatry, and it's basically saying, with the same intervention, you can potentially treat a very broad spectrum of mental illness. And so, what is that space? What is that core space in the metaphorical Venn diagram? This space where things overlap, that is targeted by psychedelic therapy. And here I'm suggesting it's negative habits of mind and/or behavior. You might think of them as biases. And so with an effective intervention, you'd want that to come in and relax those habits, take away the weight of those habits, so that you have an opportunity to, over time, revise those negative habits. Now, I just want to give you 3 summary slides of the acute action of psychedelics on the brain, being mindful, of time and the fact that I'm going terribly over time. So you might be familiar with these images. This is psilocybin, LSD, now DMT, increased global brain connectivity under psychedelics. If you look within brain networks like the default mode network, we see them break down. So their integrity breaks down while the global integrity of the brain seems to increase. And these effects correlate with certain aspects of the experience, like ego dissolution. The entropic brain is a simple principle which refers to the randomness or unpredictability of ongoing brain activity and how that relates to subjective experience, whatever your state of consciousness. If you fall asleep, activity becomes very predictable and consciousness is depleted. You usually lose it entirely. In normal waking consciousness, much richer, less predictable. Under psychedelic, that property is enhanced even further. Very unpredictable, and the quality of conscious experience is especially rich, unpredictable. We inhabit a state of relative uncertainty. So this principle is just saying that these things are related. It's increasingly well backed up by our different studies and other studies as well, and other states as well. I'll end on predictive processing. Here's a little optical illusion. There's no motion in this image at all, yet you might be hallucinating it, because if you see something like this in nature, ordinarily there is motion. So based on the fact that we've been primed, we've learnt those relationships, we hallucinate it. And this is an example of how the brain works, that much of our experience is governed by our assumptions that we've either learnt through our lifetime or our ancestors' lifetimes, and we've inherited those assumptions. And the principle with psychedelics is that the weighting of these assumptions, these internal predictive models, is decreased under the psychedelic. And that potentially can explain how we can work on the relaxation and revision of pathologically problematic biases in thought and behavior that underlies so much of mental illness. That's the principle. It's being tested. Things like the phenomenology of the experience itself. What's ego dissolution, if not the dissolution, the breakdown, the de-weighting of a very pervasive assumption that we have, that we exist, and as entities with a particular story, perhaps we always meant to exist, and we somehow existed before we were born into the world and will exist after we die. That kind of absolute conviction in the ego version of self is something that breaks down very profoundly under psychedelics, and that would relate to this principle of relaxing, collapsing, really, that very core assumption that dominates our normal waking consciousness so much. The fact that visual imagery comes up and emotion and memory speaks to the kind of yin to the yang, where if you lose the suppressing ego, then things can percolate up into consciousness. Now, to put a bit of brain on the mind, so to speak, there are a few different bits of evidence that are now supporting this model. One of the most exciting for me has come from a collaboration with a team based in France, which is looking at traveling waves. If you drop a stone in a pond, you see the waves traveling out from from the source of the perturbation. If you look in the brain during normal resting conditions, you see waves traveling from the front of the brain, the frontal cortex, high level, to the back of the brain, the visual cortex, lower level. That's what happens during eyes closed rest. What happens when you stimulate people visually? Well, the direction of the waves shifts, and they go from the back to the front instead of from the front to the back. So the front to the back being a top-down suppression, you stimulate visually, and you get this bottom-up information flow. Basically, we threw psychedelics into the mix here. This is a new finding for you, not yet published, really driven by these amazing people in France. DMT essentially replicates what happens with visual stimulation, except people have their eyes closed. You've got your eyes closed. Ordinarily, the waves travel from the front of the brain, from the high level to the low level. They suppress things. Under DMT, it's like the lights are turned on, and all of a sudden, the waves are traveling from the back of the brain to the front of the brain. Incredibly beautiful, dramatic finding, correlates very tightly with the subjective ratings, ratings of imagery. Really exciting finding that we're writing up at the moment. Let me end on this. I said I would, and I'm sorry that I've gone over time. It's our recent trial. We've got 2 big studies that have just been completed, and let me just mention this as we close. This is a head-to-head 2-arm trial, 2 sessions of psilocybin versus 6 weeks of escitalopram. We did 15. COVID-19 got in the way of 3 dosing sessions of 118. So we managed to do 115 dosing sessions, 59 patients treated twice. We balanced for everything, all the psychological contact, the taking of capsules. It's all balanced throughout, except in one condition, you get a big 25 milligram dose of psilocybin twice, or 6 weeks of escitalopram. And in that condition, you get just 1 milligram of psilocybin in your treatment session. Remarkable outcomes from this study. I wish I could say more, but just let me tease you with that. It really is something that can help, in my mind, kind of calibrate where we are. You know, for the skeptics coming to this, why should we be excited about psychedelic therapy? Let me tell you that this trial will really drill home that message as to why we should be excited about the potential of psychedelic therapy. So just to thank you for listening, thank the team and those who supported our research, without whom really I think our research probably would have collapsed. If we had to try and rely on mainstream funding, we wouldn't have a research team, we wouldn't have a center very much floated entirely really by philanthropy money. And so hugely grateful to those who supported our research and the amazing team that we have in London and our collaborators as well. So thank you very much for your attention again.
Well, thank you, Robin, so much. Can I be heard now? Yes. So thank you so much. There are a tremendous number of questions, but I do want to point out that for those who would like to ask questions and haven't yet done so, go to the questions tab on the GoToWebinar screen. Generally, that appears to the right, the way it's usually configured. And Robin has graciously agreed to share his slides afterwards, so we will be sending that out to all participants. In the remaining time, we will go through some of the questions that we can think. So neuroplasticity, can you comment on work that has been done in human subjects and exactly where we are in that in terms of understanding exactly what neuroplasticity and synaptogenesis is occurring versus and what that really means? How much is speculative, how much of it is?
Yeah. So the work that's solid is in animals, in non-human animals, where invasively you can administer the psychedelic over a particular period, particular doses, then you essentially kill the animal and look at its brain and see that the neurons changed in their anatomy. That's been the majority of the work, or you use some other marker of nerve growth, essentially. Something called BDNF has been looked at. In humans, it's harder because you don't do the intervention and and then kill a person. And so you need a non-invasive marker. And so people have looked in the periphery at things like markers of plasticity in the blood. They're a bit, a bit weak, I think. Where we're going now, which is quite exciting, is to look at things like tractography work in humans. This is something that that was the other big study that I didn't tell you about. It looks at before and after changes in the brain, both functionally and anatomically, after someone's first big ever psychedelic experience. So a bit like the neuroscience version of the classic Hopkins work that looked at changes in psychological variables after someone's first big psychedelic experience. What changes when people change after a psychedelic? So we're yet to do the tractography work. There's other ways to look at this. We've got a long-term potentiation paradigm, which involves visual stimulation and then an EEG readout of functional plasticity. So indirect marker, we know it relates to plasticity in animals. So how animals respond in this behavioral paradigm relates to if you then kill the animal and look at their brains and you see actual plasticity that's occurred. So it has been translated in that way. We've ran that paradigm in humans. And there's also a PET marker of synaptic integrity that collaborators, colleagues at Imperial are presently looking at or planning to look at with ketamine as the intervention and later on classic psychedelics. So it's a strong assumption, but it's not fully established in humans that you get neuroplasticity with psychedelics.
Okay, thank you. Related to that, a question: what is the relationship, if any, between the default mode network activity and neuroplasticity?
Yeah, another great question. So one way that we've addressed that in our current work, sort of joining the dots between measures. I talked about entropic, the entropic brain principle. The measure that we use there is a measure, we call it, it's called Lempel-Ziv complexity. We think that that's related to plasticity. The more random the activity is, the higher is the state of plasticity. And we're correlating that with the LTP paradigm, arguably more solid measure of plasticity, to see if these things relate. What we have found from our work with DMT is that that entropic brain effect that you see acutely relates to a breakdown in the default mode network. So those things are related. Basically, a lot of the things that are pretty solid when you look in the brain under a psychedelic, like the entropic brain effect, really solid. Drop in alpha power, really, really solid, reliable. Breakdown in the DMN, breakdown in networks, just so reliable. And now this global connectivity as well. It just stands to reason if these are things that you see and they're reliable, they interrelate. But the more intriguing question is, that big knowledge gap that exists at the moment, what changes when people change after a psychedelic, not during, but after? That's a knowledge gap that we're currently working on. But a little spoiler there, we have found that putting an EEG cap on when somebody is having their first ever big psychedelic experience and seeing the entropic brain effect, that is predictive of long-term changes in brain function that we've seen in that study. So we have seen those changes. So if the question is, does your brain change in the long term after a psychedelic? The answer is, it seems that way. According to our findings, it's a functional change. We don't know if the anatomy changes. We're still working on that. But the brain networks do seem to change. And what happens acutely in the brain relates to those longer term changes.
Great, thank you. It's interesting how these questions sort of segue together. Utilizing that, you use the expression well-being. Is well-being something that can be measured? And if so, how do you go about measuring it?
That's a great question, because a lot of people think it can be measured. And there's this curious phenomenon where At least so I've heard. There's a lot of sort of infighting in the positive psychology community, where everyone thinks that their measure of well-being is the best one, you know, whether it's flourishing or, you know, or something else. What seems to be the case is, yeah, sure, there's a lot of these measures, you know, very strongly interrelate. They correlate with each other. There might be some different factors related to things like resilience, which you might think of as, rather than being related to being well right now in the here and now, something like resilience might more relate to staying well. You know, if adversity comes, how well do you adapt? How much flex do you have when hit with that adversity? Perhaps something that might seem especially relevant where we are right now. So yes, I mean, we've got a paper that we're working on at the moment that basically in one of our studies we used more or less the whole shebang in terms of about 5 or 6 different well-being measures, because we couldn't decide which was best. So we thought, well, why not at this stage, at least at this explorative stage, let's use them all, see which ones are most sensitive, and see whether they fall into different components. And that's what we found, that we have found that some speak to being well and others speak to staying well. And another spoiler, both seem to be promoted after psychedelic use in our survey work and also in our controlled research as well.
Great, thank you. Again, sort of segueing into, can you talk about the difference between SSRIs and psychedelics and how they work similarly as well as in opposite ways on serotonin?
Yeah, well, they both work on serotonin. So, you know, people might look at that and think, oh, you know, maybe psychedelics are just like a basic pharmacological action, like was seen with drugs like Prozac. And there I would say there are some key differences. So whereas, you know, drugs like Prozac, escitalopram, the comparator drug in our trial, these are SSRIs. They're basically blocking the reuptake of serotonin into the cells, and so that means that there's more serotonin floating around, and that's you know, contributed to this principle of more serotonin, very broadly speaking, floating around in the brain, being associated with better mood. You know, the action of SSRIs is basically more general. It's increasing serotonin, which, as I said earlier, has 14 or so different receptors. Some of these SSRIs also work on more than just serotonin. And so you get this very broad brush, non-specific action on the serotonin system. And like I said earlier, you know, these receptors often do quite different things to each other, sometimes opposite things, counteracting things to each other. One receptor might excite cells and others might inhibit cells. And so what, on a more kind of intuitive psychological level, what SSRIs seem to do is take the edge off things. And on a more sophisticated neuroscientific level, they seem to possibly do that through damping the stress circuitry, so that the stress circuitry is less active and responsive. That seems to be a principle relating to the action of SSRIs, and that might be why it feels like they kind of flatten the peaks and the troughs of lived experience. They help you get by, but then people will say, you know, I had to live 2 years to get 1 year in terms of life experience. I felt depleted being under the SSRI. With psychedelics, it's more that they say the opposite. They feel rejuvenated, like a psychological rebirth. You know, everything is vivified. They feel like they're really living again, you know. So how do you summarize an effect like that? Something I've used in the past is to refer to emotion and say, whereas SSRIs might maybe blunt non-emotionality, psychedelic therapy is more like a release of emotional material. and then the possibility to work through that material and learn from it.
Great. Well, Robin, there are so many unanswered questions here, both in general and specific to this group, but we have reached the top of the hour. In truth, this could have been a 2 or several hour call, which would have been a session, which would have been absolutely fantastic, and we would all be grateful for. As a matter of fact, Robin and I will talk afterwards about possible ways of sort of reconvening, because there are a tremendous number of great questions here. The next global conference call will be, the next regularly scheduled global conference call will be in May, but again, I'll have a conversation with Robin here. For those who are not yet in who are in YPO but are not yet in the YPO Psychedelic Medicine for Mental Health group, I would encourage you to join to make sure that you receive notice and all sorts of other information and opportunity to share. We will also be circulating a survey to everyone regarding their areas of interest. So we've had a number of really interesting and informative learning calls, which is great, and we totally intend to continue that. But to the extent others may have areas of potential action that they are interested in or specific focus, this will give you an opportunity to provide feedback on that. So again, I thank everyone. Be safe, be healthy. Robin, thank you so much. We will be sending out a link to a recording to be shared, as well as to Robin's slides. And again, everyone, thank you so much, Robin. Deep gratitude.